Hello, everyone. Thank you for joining today's SIA-sponsored public webinar, Turning the Tide for Semiconductor Manufacturing in the United States. My name is Falani Noog. I'm the Director for Industry Statistics and Economic Policy at SIA. Before we get started with today's webinar, I want to let you know about our next upcoming webinar, which will be on Tuesday, September 29th. We'll have a distinguished panel talking about the trends and challenges in advanced packaging. So please look out for an invite for that in a couple weeks on, again, Tuesday, September 29th. I believe it's scheduled for 11 a.m. Eastern Time. So turning our attention to today's webinar, I am very pleased to have a distinguished panel of experts to talk about a very, very timely issue. As you know, Congress is currently considering legislation that could call for substantial investments in domestic semiconductor manufacturing and research. Just this week, SIA and the Boston Consulting Group released a joint report analyzing the impact of such proposed federal incentives on domestic semiconductor manufacturing. So to discuss the report findings and also to discuss what these findings mean in terms of policy and for the leadership of the US semiconductor industry, we have a distinguished panel of experts. Let me go ahead and introduce them and then I'll turn it over to the panelists. First, we have Antonio Barras and Raj Varadarajan, both senior partners and managing directors at the Boston Consulting Group. They're also both co-lead authors on the report, along with a couple other folks from SIA. Antonio is a core member of BCG's technology practice, based in Silicon Valley with 20 years of experience in semiconductors, smartphones, and connected devices. He has deep experience in the semiconductor industry, where he has served leading global companies across the value chain and all end application markets, particularly in issues related to strategy, corporate development, and growth acceleration. Raj also leads BCG's global advantage efforts in North America, which includes geopolitics and trade and public-private sector collaborations, and is also a senior leader in BCG's TMT, or Technology, Media, and Telecom practice. Raj has over 30 years of experience working with large clients in multi-year transformational efforts across sectors, including the semiconductor industry. And he Antonio recently co-authored another report that with SIA back in March, how restricting trade and China could end US semiconductor leadership. Both this report and the one released this week are available on the SIA website, www.semiconductors.org, as well as the Boston Consulting Group website, www.bcg.com. We also are joined by James Lewis, Senior Vice President and Director of Technology Policy Programs at the Center for Strategic and International Studies. James has authored numerous publications on the relationship between technology and innovation and national power. Before joining CSIS, Lewis worked at the Department of State and Commerce as a Foreign Service Officer and as a member of the Senior Executive Service. And James is frequently quoted in the media and has testified numerous times before Congress. Finally, to provide an industry point of view of the report and this proposed legislation, we have Greg Slater, VP Manager, Intel Policy and Technology Affairs Organization at Intel Corporation. Greg has held a number of other executive roles at the company besides his current one, including General Counsel for Intel China and VP of Global Regulatory Affairs. Before joining Intel, Slater practiced law at Latham & Watkins and Steptoe & Johnson. So with those introductions out of the way, let me go ahead and first turn over the panel to Antonio and Raj of BCG, who will provide an overview of the recent joint BCG-SIA study. Antonio and Raj.
Thank you, Falan. This is Antonio Barras from BCG. Thank you, everybody, for attending this webinar. What we're going to do over the next 15-20 minutes is go through some of the key findings from the report that was just published on Wednesday. And the focus of the report was to really look at the competitiveness of the US in semiconductor manufacturing. So the first thing to understand it is how is the position of the U.S. manufacturing different from the overall role of the U.S. in the global semiconductor industry? It is widely known that the U.S. is a global leader in semiconductors with a share of about 45–50%, very consistent year on year, of the total semiconductor sales globally. But as you can see on the chart on the left, that position is cemented a very strong position across the value chain, but it's different across the layers of value chain. The US has a strong position in design tools, the EDA, in the core IP. You see there the high share of US firms in those layers. The US also has a high share of the design and commercialization, that 45–50% I was alluding to. But when you look at the manufacturing stages, the share of the US goes down significantly, or significantly below the other layers in the value chain. Specifically on manufacturing, that is not including packaging, the US accounts for just 12% of the global installed manufacturing capacity right now. Perhaps what is even more interesting is to see how that 12% of manufacturing compares versus the share of manufacturing in the US in other industries. That's what we try to represent on the chart on the right. And we pick here is, industries that are widely considered as strategic for the US economy and national security. So as you can see on the right, that 12% is also significantly below the share of the manufacturing portion of the value chain that the US has in industries like aerospace, medical equipment, pharma, petrochemicals. It is only above the share of manufacturing that the US has in other technology activities that are much more labor intensive, like assembly of hardware for technology infrastructure or consumer electronics. So clearly a share that is well below what is typically considered a reasonable share, both in terms of relative to other layers in the value chain and also other strategic industries. Now, this has not always been the case. In fact, the 12% that we see today is the result of a long trend of decline in the last 30 years. Back in 1990, the US accounted for 37% of the global manufacturing semiconductor capacity. But that 30% has been going down over time. And what you see in the chart is in parallel to that decline, the share of Asian countries, namely Korea, Taiwan, and in the 2010s or so, China, has been growing steadily. Now, it's important to note also that that declining share has not been driven by lack of investment. In fact, what you see at the bottom, we put there the growth rates in capacity. And you can see that the US actually has been growing the installed capacity at a very healthy 7% CAGR over the last 30 years. But given that this semiconductor industry is a high growth, that investment has been outpaced by Asian nations that have made investment in the manufacturing sectors a national priority. So what this leads is, if you just extrapolate the current momentum, we would expect the US share to continue declining to about 10% at the end of the next decade. And by the end of the next decade, we would expect East Asia, so the sum of Japan, Korea, Taiwan, and China, to account for 77% of the global capacity. And China, on the back of the aggressive investment policies that the government has put in place, could emerge as the #1 location in terms of installed capacity, with 24% of the global capacity by 2030. Now, why this matters? We believe that this trend has profound implications for the industry and therefore also for the US economy and national security. Briefly, there's three main reasons. The first one is a strong position in manufacturing is critical to sustain the US leadership in semiconductor innovation for the long run. So manufacturing within the value chain has a central activity. In fact, it accounts for 45% of the value added of the total industry and about 20-25% of the total R&D. So a very significant portion of the activity in the industry. And moreover, if we look at the pace of innovation in the industry over the last 50 years, that impressive and relentless improvement in both performance and cost has been driven by innovations manufacturing, Moore's Law, or the extra efficiencies of the fabless foundry model. And going forward, we expect that also to be the case. In fact, as is known, the industry is now investing in the next frontiers of innovation on materials, chip architectures that will require a close collaboration between design, manufacturing, and equipment. So having a strong position in manufacturing will be critical to really lead the world in the next technology breakthroughs that will make technologies like AI or quantum computing a reality. The second reason is it should be obvious that having more than 75% of the global capacity concentrated in a relatively small geographic region like East Asia poses the question of supply chain resiliency. In particular, because this region is known to be very exposed to risk of natural disasters. In fact, all these countries are on what is called the Pacific Ring of Fire, with a high risk of earthquakes. And then obviously, also in the last few years, this region also is heavily exposed to geopolitical frictions. On top of that, I think also the US government has recognized that semiconductors are critical components for aerospace and defense systems and critical infrastructure. So there's an increasing need to, from a national security perspective, to have at least a portion of the supply chain that is trusted and secure. And finally, given the importance of the industry, there's additional benefits for the US economy that will come with a stronger manufacturing footprint in the US. In terms of the development of high-tech clusters that create high-quality skilled jobs and also economic prosperity. And examples of those already exist in the US in places like Oregon or Arizona or Austin, Texas. And so given the position of US industry in the design and commercialization of products, and this could also contribute to an increase or expansion of the US exports of goods. So three big reasons why this trend should matter and should be should require attention from policymakers. Now, having laid out the problem statement, the question we ask ourselves in the report is, why is this happening? Why the US is not or has not been historically in the last 30 years an attractive location for fabs. So we gather both input from the companies that are involved in manufacturing, and also we build an economic model to look at the economics of fabs in different locations. So what you see now here on this chart is represents the view of the industry. We ask the companies, what are the critical factors that you consider when you look to make a selection of a site for a new fab? So these are the top 5 that came back from that dialogue. It's interesting to see that the US is very well positioned in 3 of them, those that are colored in a green background. But clearly also the message is that the US has a significant gap, in fact it's almost an outlier, on the 2 that are colored in red, labor cost and government incentives. Those 2 have to be the ones that have to do with economics. So the message from the industry is very clear. The industry, or the perception of the companies, is that the US is not competitive in economics and manufacturing, but is competitive in other factors that don't have to do directly with the cost structure. So given that message, we build an economic model to actually see if the numbers support that perception that the industry has. So we model the total cost of ownership that includes both the initial investment and also the operating cost of running a fab over a period of 10 years for 3 types of state-of-the-art fabs. Obviously, these are not the only fabs that will be built in the next 10 years, but it offers a good representation of the different type of fabs. So one for advanced logic in the leading node, advanced memory, 3D NAND, and also advanced analog. So we model the cost across different locations. The first message on this slide is, obviously, and all of you that are in the industry know this, is the cost of building a new fab, a next generation fab or a state-of-the-art fabs is incredibly high. We're talking for advanced logic of an initial investment of 20 billion, add to that about 10 billion in OpEx over 10 years. That cost, just to give you a reference, exceeds significantly the cost of very expensive, like the next generation aircraft carrier. So and you see a similar thing in memory, and up to 13 billion of total cost for advanced analog. So these are facilities that require a huge investment and are also very capital intensive. I think the second thing that you see here is that the government incentives have a very material impact on the economics. So the third column that you see over here is the government incentives that offset part of that investment and cost. So across the three types, our estimate is that government incentives can account for anything between 15 more or less and 40% of the fab total cost. Obviously, that is a very significant percentage that also given the very large number, or very high number of billions, so the cost is a very material number. Also, we want to highlight here that we found a very significant difference in the level of incentives that is provided by different countries. So what you see here in that range with the dotted third column on each chart is represents the two extremes in the range of countries. The US happens to, according to analysis, happens to be the country with the lowest level of incentives, all incentives being state and local. China is the other extreme, with the highest level of incentives. But countries like Taiwan, Korea, or Singapore do offer to companies incentives that are around 2x the level of incentives that the US provides for new fabs. What this means is that when you take everything into account, the cost of building and running a fab in the US is about 25% higher than it is if you run that fab, build and run that fab in South Korea, Taiwan, or Singapore, and about 50% more expensive, or up to 50% more expensive than you run it in China. So that's what you see represented here in index terms. So 100 is the US, and then in index to 100, the other locations. So a very significant gap, or around 25%, 50% across any type of fab. Obviously, this explains why the US is not perceived to be competitive in economics for fab building and operation. And what we put here at the bottom is actually what portion of that incremental cost that the US has is directly linked to government incentives. So the numbers are different by country and fab, but if you look across the board, 40 to 70% of that extra cost that a company must bear if they build a fab in the US versus another location, 40, 70% of that extra cost comes directly from government incentives. So clearly, government incentives, they have a very material role in the perceived lack of competitiveness of the US in manufacturing. Given that, in defining the question was what to do about it. So in partnership with the SIA, we developed a model to look at what would happen if the US was able to set up a new investment incentive program at the federal level that would provide economic incentives for new fabs built in the US over the next 10 years. We picked the next 10 years because we actually saw that given the strong growth expected in this demand for semiconductors, the world will need a lot of new capacity. In fact, we estimate in aggregate, the world will be adding 50% more capacity versus what is installed today. So there's a real market opportunity for the US to increase the participation in that growth. So by no means we're arguing here or just building capacity in the US to create an overcapacity in the industry. There's real need for more capacity. So what will need to happen for the US to participate in that growth? So what we model here is that it's three scenarios. The status quo and then two levels of incentives, one at 20 billion over 10 years, another one at 50 billion over 10 years. So as a reference point, in the last decade, in 2010 to 20, the US was able to attract 10% of the new capacity in the world. What we see in the fabs that are currently in development is that the US only accounts for 6% of the new capacity that is already in progress. So this is not a forecast, this is a reality. So the status quo, do nothing, would expect the US to be able to attract a similar number. So the model here is 6% of the new capacity. That would continue putting the US at the bottom of the countries that have a role in the semiconductor value chain. So the number 5 is the bottom of those, and essentially lead to that additional decline in the share at the end of the next decade. So going down from 12% to 10% in 2030. With 20 billion over the next 10 years, the US will be able to make the economics a bit more attractive by leveling the playing fields in incentives versus other locations. So with 20 billion, we would expect the US to be able to attract 14% of the new capacity. And essentially that would lead to keeping the US share constant at the end of the next decade. So the US will be able to hold the 12% that currently has in 2030. So that's the minimum to maintain the share. Now, what we model is what would take for the US to reverse the trend and actually start taking some share. So according to our calculations, you will need to attract 24% of the new capacity. And in order to do so, you need $50 billion of incentives over the next 10 years. So that's not 50 billion per year, that is 50 billion over 10 years. With that, we estimate that the US will be able to multiply by 4 their participation in the new capacity, so going from 6 to 24% of the new capacity. And that will put the US as the second country in terms of capacity growth, only behind China. And essentially that would allow the US to reverse the trend and over the last 30 years and start gaining some share. And the incremental capacity, probably in terms of volume, should be enough also to cover the requirements of the US in sectors like aerospace and defense, or the sectors more sensitive from a national security perspective. So that is the summary, brief summary of the findings of the report. There's more data and more analysis that you can find in the report available on the SIA or the BCG website if you're interested in.
Great. Appreciate that overview, Antonio and Raj. You put a lot on the table, and there's a lot of information in the report. I'd like to now turn to you, Jim. Jim Lewis of CSIS, to give us your perspectives on sort of the national economic security implications, both of where we are now in terms of our share of manufacturing for this industry, and what do these incentive scenarios for could mean in terms of our national and economic security position.
Thank you, and thanks to everyone for being on the call. You know, I think we all know that we're in a contest with China. The exact nature of it isn't clear, but relations are getting worse. And the Chinese have realized that semiconductors are a strategic industry that they want to bring to their shores. And as you heard, we used to have a very strong position, but it's been eroded. So part of what we're doing with these kind of incentives is just leveling the playing field. The OECD put out a report a year ago that said there's a dozen or more countries that offer significant subsidies to attract the semiconductor industry to their territory. We need to match that. It's just, you know, to keep the playing field level. Second, there's been a lot of attention to supply chain security. People feel more comfortable with a domestic supply chain, and COVID has only reinforced that. But the most important thing is semiconductors are a strategic industry. It's not an industry that we can afford to see leave these shores or degrade. And if you think about what would happen if the US couldn't make airplanes anymore? What would happen if the US couldn't have its own space industry, if we were dependent on foreign suppliers? Everyone would call that a huge strategic error. And we've seen this now because we let the American companies that once led in building telecom infrastructure, we've let them go out of business, right? That was what we call a strategic blunder. So I see this as crucial for reinforcing the US position in its contest with China and as a global leader, both economically and militarily. Why don't I stop there?
Okay, great. Appreciate that, Jim. Now we want to turn over to Greg Slater of Intel Corporation to provide a point of view from a U.S. company. So Greg, why don't I go ahead and turn it over to you? I'll go ahead and you sent me some slides, so I'll go ahead and share the slides that you have.
Yeah, I may not use all of them since BCG did a good job with data. Just a quick comment on what Jim just said. He said, what would happen if the U.S. no longer made planes or I can't remember what you said, aerospace, got involved in the aerospace industry. Actually, semiconductors underlies both those industries, right? So you can't think of the semiconductor industry in isolation. It provides the foundational blocks, the building blocks for the digital economy. And for a lot of other industries, in terms of automation and digitization and being more productive. This chart right here shows a little bit more about what BCG was talking about. This chart was used by ITIF in a panel they did yesterday, that Jim actually participated in. And it's just basically the migration of value add to Asia over the last 15 years, or between 2001 and 2016. And except for Japan, you know, other Asian countries that have a semiconductor industry are increasing in value add. We're maintaining somewhat of our share because of the design and IP parts of the semiconductor development process, as BCG insinuated. Next slide. I'm going to go over these quickly because I want to make some other points. This is a little bit of an eyesore, but it's an interesting chart. At the bottom, it describes the part of the semiconductor supply chain, if you will. CPU design, graphics, networks, the manufacturing and packaging in the middle. That's what I want to focus on. Memory and other things. And the blue is our US share. And the black and the other shaded other colors are other countries. And you can see the migration here, or the erosion, if you will, in the US, where we're strong and where we're real weak. And of course, the middle is the core of it all, as BCG said. There's synergies between design and manufacturing, and that's why Intel believes in the integrated design business model, because, you know, design manufacturing model, because of these synergies. And once you lose one part of the industry, it's easier to lose another part. So packaging and assembly migrated to Asia first. Then manufacturing started migrating, and now even going upstream, there's more migration. So that core is really important to maintain. The top is just the metrics that are used. And so there's just a heavy dependence by US companies on overseas manufacturing and packaging. That's not only bad for supply chain purposes, but it's also bad from an R&D and innovation perspective because of the synergies I talked about. Next slide. This is a slide from SIA that just shows the continued migration of manufacturing in and towards Asia. And BCG already mentioned we're at 12% now, US share, and it'll drop to below 10% over the next decade. And that'll continue unless, of course, we reverse it through government incentives. Next slide. This is an interesting slide that actually shows the erosion of US manufacturing. And there used to be a number of firms back in just 15, 20 years ago of US firms, and those are in blue. This is on the right, and they have decreased to basically 1 on the leading edge, and there's a few others left over. And the reason is, on the right, on the left, you see the escalating costs of building a manufacturing fab, especially on the leading edge. It's just astronomical. And so the erosion is just not going to stop without any kind of help. Okay, next slide. And this is the incentives that are available in different parts of the world. And there are state incentives in the US, but there's no federal incentives. And it makes a big difference. 3/4 of the cost differential is between the US and, for example, Asia is related to incentives, whether it's tax benefits or grants or reduced costs on utilities or free land or whatever it is. And the higher the CapEx, the bigger the incentives, the bigger difference the incentives make. And so, as the BCG report points out, the cost difference is up to 30% between the US and Asia, which is huge when you're talking about a $10 or $15 billion fab. Okay, so I wanted to, we've talked about incentives, and the question is it a good deal for the U.S.? They may be supporting the U.S. industry, but is it a good deal for the U.S.? And before I answer that question, what is on the table? As many of you know, we basically right now there's a federal grant program pending before Congress as part of an amendment to the NDAA, a merger between the CHIPS Act and the American Foundries Act that got a lot of bipartisan support, but it has no funding right now. Originally, $15 billion was proposed, and then there was a fair amount of money allocated to R&D, but all those monies got stripped out by the Appropriations Committee. The question is that a lot of money? And BCG says, well, we really probably need $50 billion. The original bill, I think, was up to $29 billion with the R&D funding. Depending on which version you're looking at, also Senator Cotton's bill had an investment tax credit. For a whole industry, to incentivize the whole industry, that's actually not a lot of money if you consider that one fab costs, $10 billion or more. Intel alone put in $29 billion and change just last year on CapEx and R&D. And, split almost half between CapEx and R&D. We are one of the most capital-intensive industries around, and Intel is the 5th largest spender in the world on R&D. So it's not like we don't plow our profits back in to make this happen. And for Intel, a lot of manufacturing is in the US. The majority of it is. But we could have more in the US if we could close some of that gap. The grant program, depending on how you calculate it, if a project were to max out at $3 billion, with a grant at $3 billion, which right now the legislation caps it at $3 billion per entity or per project, there's a little clarification that's needed there. That would close perhaps 5 to 7% of the cost difference between the US and Asia. So it's going to help, but it's not going to completely level the playing field. And so that's why we also need investment tax credit. So just a quick point on whether this is a good deal. Let me just tell you from an Intel perspective what we contribute to the economy. In 2012, a Price Waterhouse study was done on our impact. And it's a little dated, and we're updating that study, but the statistics are pretty interesting. First of all, the average salary for a leading edge a company in our industry is about $150,000 per year. The average salary, that's total comp. We're on the high end in terms of compensation. And because of our 50,000 plus jobs in 2012, Price Waterhouse estimated that our US GDP contribution was around 100 billion in 2012. And actually over 400 billion in the period between 2008 and 2012. The total impact on labor income was 52 billion in 2012 and over 200 billion between 2008 and 2012. And so the semiconductor industry is contributes a lot to the economy. If you go just to our Oregon facility, we supported in 2016, this was an Oregon study specific to our operations there, we supported $27 billion in economic activity across the state. And the average job that we supported, not the Intel job that makes 145 to 160,000 depending on which location, in Oregon, the average job that those jobs supported or our activity supported was over 100,000 in labor income compared to a statewide average of 59,000. So this is, in our opinion, the incentive legislation not only would prevent the continued erosion of manufacturing to Asia and all the benefits that you get from that, whether it's supply chain, resilience, security, or the R&D that comes with having U.S. manufacturing. I think BCG said there's a 20 to 25% value add of R&D related to manufacturing. They can correct me if I'm wrong, but there are definite synergies there. We can attest to that. But it's also the jobs and the indirect economic impact. And it's the value added to our increased productivity from manufacturing leading edge products, as well as the technology leadership generally, because they are foundational blocks to so many other industries, and the military leadership. Of course, military relies more and more on automated weapons, and at the core of those weapons are semiconductors. So just to wrap up so that we can make sure we have plenty of time for questions and answers, the data that BCG has is extremely important. The erosion of the industry will continue unless we do something about it. 30 plus years ago, the intelligence community and DoD in particular raised a flag about this problem when the assembly test was starting to migrate. And we haven't really done anything about it. So SIA, Falon, back to you.
Great. Well, Greg, appreciate those comments, certainly about the overall economic benefits of the semiconductor industry and of Intel in particular. That's something that obviously SIA likes to let people know about. Often people don't really understand the incredible importance of the semiconductor industry, as you said, to downstream industries, airline industries, others, as well as just the overall economic benefits. I do want to be sure that we have time for Q&A. I would remind folks, please go ahead and send in Q&A. We've got a couple already. I'll try to round up the questions and sort of mention them to sort of give them to folks on the panel. But why don't I go ahead and get started a bit and do a little quick round of some Q&A to our panelists. Just to build on some of the findings, back to you, Antonio and Raj. I know you did a lot of research on this. We worked very closely together. I'm curious if there were any conclusions or insights about the state of domestic semiconductor manufacturing or the impact of the incentives that surprised you at all?
Paul, I think that while we were anticipating some difference, I think how stark the difference was in the TCO was something, the total cost of ownership, which I got a quote. I think there was a question in the chat. It does include the CapEx and 10 years of OpEx, if you will, which is both the labor costs and other OpEx costs. How stark that difference was surprised us. Particularly, it's very surprising to find this kind of a cost differential in a highly capital industry with more than 50% of the cost base. If you look at over the 10-year TCO, more than 50% of the cost base is globalized inputs. So it's around equipment and recurring O&M and materials and things of that sort. And about less than 50% is in the labor and utilities and taxes and construction, which are all localized costs. So when you have that much of the cost base that is globalized, one would think that to find that much of a difference in TCO was surprising, and it's mainly because of government incentives, which were making the U.S. a non-attractive location. So all the things that Greg said, in terms of the value add, it's very clear. And the point to emphasize is that any one of these incentives is really just to level the playing field, because the same amount of value add would happen to the world, except that all of that stuff would go wherever the incentives were, and there's a non-level playing field, and the extent of that was surprising to us, at least.
Yeah. Thank you. Just another couple comments to add on to that. I think certainly from my point of view, understanding that the semiconductor market is a growing market is very important, I think, for folks, especially policymakers who are considering investing in domestic manufacturing, to know that this isn't an industry that's dying anytime soon. In fact, I think we had a panel a couple months ago where one of the industry experts in the financial community said that he thought that the industry would grow pretty soon to eclipse $750 billion in total market size, which right now, the industry was about 412 billion last year. So a lot of runway. And as Antonio and Raj have mentioned in their comments, a lot of white space or fab capacity that's unaccounted for, a great opportunity for the U.S. to sort of to jump in there and have fab capacity built in the U.S. The other thing too, I've been working following the industry for several years now, and one thing that really surprised me is just how quickly the average fab total cost of operation, TCO, or certainly fab construction costs, have just skyrocketed over the past decade. I think this was highlighted in one of your slides, Greg. But I mean, it wasn't that long ago that we were talking your average fab or your state-of-the-art fab was $4 to $6 billion. Now we're talking 20 billion just to construct, and upwards to almost 40 billion to construct and operate over 10 years for a leading memory or logic fab. So yes, this is an industry that is highly capital intensive, highly R&D intensive. The costs are just pretty stark, pretty astronomical, and still growing. Yeah, that's definitely something that really stood out for me. Jim Lewis from CSIS, I wanted to ask you a follow-up question in terms of the economic benefits. We talked about the economic benefits. The report talks more specifically about the pure economic benefits in terms of jobs, in terms of actual number of fabs created. But give us a sense of, when it comes to the economic security and national security point of view, what are the vulnerabilities that we face currently? And if we continue down this path over the next 10 years of losing capacity share in the U.S., like in real world terms, like what are we talking about? Would we have to depend on imports of certain products? Right now, I don't think we have sort of all the bases covered in terms of all the sub products of various components, that go into, making your iPhone work. But if one of those products is not made in the U.S., then, your cell phone, if it can't have that product in it, sort of becomes a glorified paperweight, right? So do we want to live in this world where we may be dependent on imports of a particular product, a particular component for many of our critical infrastructure, not just commercial products, that actually work?
Well, I've been looking at some of the questions in the chat, and so there's a couple numbers that we can start to help frame the discussion. Over the last 18 years, the U.S. has spent somewhere between $6 and $7 trillion on Afghanistan and Iraq, right? And that's one estimate. And so, that works out to be thousands of times more than what we're talking about here. And the benefits, as we've heard, to the economy, to national security, to the U.S. international standing, would probably be a heck of a lot greater than that expenditure. So people don't want to spend the money, I understand, and the U.S. has been declining its investment, shrinking its investment in these national security related activities for decades. And now we're in a contest. We have to pay up. Another number, somebody mentioned aircraft carriers. Aircraft carriers cost about $12 billion. And the way I've been describing this on the Hill is think in terms of 2 or 3 aircraft carriers for what we want to do with this industry as a start. So it's worth spending the money because this is a strategic industry. It produces, you've heard all the numbers, jobs. We didn't discuss Internet of Things enough. Eventually everything you own will have a chip in it. We're pretty close to that now. When you have a smart toaster or smart refrigerator, why you would want a smart toaster is another matter, but you're going to buy it, we know. And that's when you're going to say, Where does that chip come from? What does it connect to? So this is a crucial industry for us. It is the industrial base, the defense industrial base of the 21st century. And that's why the benefits, economic, military, security, justify spending at least as much as a couple aircraft carriers.
Thanks for that. We have a number of questions coming in, so I'll try to see if we can find some that would relate and add to the topics. One question I see here, do you think incentives would be only for domestic players, or will they be open to international companies as well? Greg, maybe you'd like to sort of, answer that. I know you're on the forefront of knowing what the legislation looks like, but my assumption is that it would be for not just for domestic U.S. headquartered companies, but any company, foreign or domestic, that would be interested in building and adding fab capacity in the U.S. Again, the issue is not what company or who, but that it's built in the U.S. For many of the national and economic security reasons that we've outlined.
Do you want me to address that first?
Yeah.
So I agree with that generally. I think with secure microelectronics and supply chain security concerns, there may be room for a preference to make sure that the intellectual property is in the U.S. Right? You don't have full supply chain security if you don't have that. But that's for example, there's a secure microelectronics provision in the legislation that is not totally fleshed out, where that could be a factor, right? You have a factory, you have equipment in the U.S. You don't have the IP, you don't have the whole package, or the process technology being developed in the U.S. But other than that, I agree with what you said.
Okay. I had a question I see here that is kind of interesting because it talks about labor costs, and I know Antonio and Raj, that was one of the criteria that I think in your survey showed up as being sort of on the weak side for establishing a fab in the U.S. In addition to the lack of government incentives vis-a-vis other countries. Question is, if every country keeps competing on government incentives to keep these fabs in their respective countries, do you think labor costs will be a strong determinant in the very long run? If yes, how can the U.S. edge over in this factor? It's a good question.
Yeah, maybe I'll take it, Raj, feel free to add. Well, first is, according to our modeling, again, if I take just logic as an example, labor cost per se, so labor cost of running the fab is about 6% of the total TCO. So yes, indeed, when you look at that, with the impact, this is about between 12 and 20% of the cost gap with the US versus say Taiwan or Singapore would be labor cost, given the big difference in median salaries between those two countries. But it's still a relatively small portion of the total cost. There's another one that is construction, that is a bigger number. And in construction, obviously, there's an element of labor cost also embedded there, apart from sort of engineering and project management expertise. So yes, labor costs have a role, but definitely is a very distant second factor after government incentives. Again, just to remember, government incentives will be 60–70% of the difference. Labor costs 10 to 20% of the cost difference. Now, I think the second part of the question is, well, if what will happen if the U.S. matches everybody else? So we solve the 70%. And the other countries move away. Well, the reality today is that we're even so far with a 70% difference that we should close that gap first and then worry about the 10–20%.
Mm-hmm. One other following question, I see one that sort of makes sense to add, to sort of follow on. Besides the labor cost, there is a question, a concern here about if fabs are brought back to the U.S., will there be enough jobs or qualified engineers in the U.S.? Obviously this gets to the issue of immigration policy and STEM, and how to be sure that we have a workforce that will supply these important jobs. Anyone care to comment on that? What could be done to sort of improve sort of policies to help actually meet that demand, assuming we get sort of added capacity in the U.S.?
I'll start because this came up in the discussion we had yesterday that Greg was at, and that is that, does America need a Sputnik moment? So if you remember, in the 50s, America launched a whole set of initiatives to invest in R&D, to build STEM talent, to reinforce education, after they saw this satellite floating around over their head. And we haven't had quite that Sputnik moment. There was a little discussion, did COVID count as a Sputnik moment? Don't know. But we have to match the levels of investment that we saw from the period 1950 to 1980 if we're going to compete successfully in this new contest. And people would prefer that that wasn't so. It's always more fun to get the peace dividend than to have to spend on defense. But that's what we're talking about, is a similar sort of set of initiatives as we had in the past to build workforce, to build that American talent. I will say I teach at a university, and one thing I do just for fun is ask everyone in my class, if I offered you a full ride in exchange for going into engineering and math, how many of you would take it? It's about 80%. So you want a STEM workforce, you can buy it, but you have to be willing to spend the money. And that's where we sometimes fall short.
Gotcha.
Juan, let me just add to that. You know, STEM, SIA has been at the forefront of pushing for solid STEM immigration policies, making sure we have access to the talent overseas that we need. Of course, if we had it here, we wouldn't need to go overseas, right? I mean, you prefer the talent that you have here first, access it, and then go overseas. But we need more talent. There's no question about it. And we need more talent overseas, but we don't have enough in the U.S. So SI's been and Intel's been advocating for those policies for a long, long time. That goes back to the incentive issue too. Like, we don't want to block foreign investment, but we also need to make sure that the incentives actually build U.S. technology leadership and maybe have a preference for U.S. companies, all other things being equal. So we just need to make sure that we're building up the U.S. industry, and that is more than incentives. It is access to talent.
Mm-hmm. Yeah. Roz, looks like you wanted to say something.
No, there was a couple of questions that Stacy had asked, which I wanted to get back on. I think we touched on it, but there are two sides of, like, the yin and yang thing, which is, on the one hand, with 50 billion, we only get to 13, 14% of capacity. Is this enough? I mean, that's a really good question. And, if we wanted to have leadership, we had sized some other numbers, which sound so astronomical. And I think at this point in time, we need to make a move and stop the bleed or reverse the trend, or whatever you want to call it. So that's why we put it out there first. But Stacey, that's definitely a good question. But then on the flip side, there was a question later on, which is, what if we did this and the other guys did more? And so would it become an escalation of things? And, again, that's a good question, but it's really, we don't think that if it happens, it'll be because of labor costs, labor of work generation. At least I think it's mainly, because of the fact that it is such a critical asset, right? So that having that, if it does escalate, it'll be more proof of the fact about how critical having this asset locally is. But you're right, we can't say what would happen if there's an escalation. At this point, what we laid out was, what does it take to even level the playing field?
Right.
I think those were a couple of interesting questions there.
Yeah, and I would add too, I know, and this may be a question for you, Antonio and Raj, I did go into this, but, I see a question here about, would these government incentives act to crowd out industry incentives, which is, probably an unintended consequence that no one would want. I think, that is definitely not the case. I think, this would actually, any sort of government incentive in the semiconductor industry to increase domestic funding or domestic manufacturing would actually crowd in more investment by the industry, because 50 billion or 20 billion, as you mentioned, Greg, is not getting you much in terms of number of fabs. That's a portion of the cost that gets you to be sort of more competitive with other government locations. but of course, then that is, the difference is being made up by what companies need to invest in terms of the CapEx, building the fab, operating the fab. So the report didn't do it, but I imagine, for every dollar of government incentives that the federal government, the Congress is contemplating, that this would, sort of translate into, many more dollars in terms of fab construction costs that the industry would have to invest to build, right?
Yeah, I'm happy to take that question. Yes, indeed. The way we conceive the incentive is like a fund directly tied to fab projects. So it will not be a blanket subsidy provided to specific companies or manufacturing activity in general. So it's project by project. And Falan, to your question, again, if I pick the $50 billion incentive scenario, and the industry will need to simultaneously invest just in CapEx about $280 billion, because again, the incentives do only offset 30–40% of the total cost. So it's not that the government will be paying for the new fabs. The industry will need to commit a very significant amount of money to.
Right, and that's just CapEx for the construction, I imagine, for the initial construction. But as as the report shows, there's a cost of operating the fab, and most of those costs, I imagine, are the majority of those costs compared to the CapEx initial construction are probably more a cost that the industry would have to bear instead of government incentives playing a role. Government incentives, in terms of the analysis that governments offer around the world, play more of a role in the initial construction, though there is some in sort of the operations. Great. I know we're getting close to time. We have a ton of questions. I really appreciate all the interest and insight. Let me see here. I'm trying to pick out one here. If folks is there anything, I should ask the panelists, is there any topic or any area of this discussion you think we have not sufficiently covered, or that we should let the audience know about?
Well, there was one question. I was thumbing through 39 questions.
Yeah.
One question, we're using a narrow definition of manufacturing. What about equipment or design, and so the legislation is broad, right? It talks about packaging, manufacturing, modernizing fabs, not just new fabs. So it would allow a lot of manufacturing activity, and it's not limited to cutting edge. I just wanted to clarify that.
Mm-hmm. And Greg, correct me if I'm wrong, but the legislation also, I think, is contemplating incentives for R&D or research, right? So this is not
both pre-competitive and applied research. So yeah.
Okay, that's a good point we should underscore. And I will mention SIA does have information. We did an earlier study this year looking at the impact of pre-competitive basic research by the government in the industry and on the U.S. economy. A report entitled "Sparking Innovation." So I would encourage folks to take a look at that when they have a chance. I think we are getting close to the top of the hour. I do want to leave the last couple minutes just to wrap up. We have a ton of questions. Again, I appreciate all the folks who joined, listened in. This is a very timely issue, as you know, in terms of what's going on in DC with policy and just in general, where our industry is going in terms of the U.S. competitiveness on the manufacturing front in the United States specifically. I want to thank our panelists for joining. Really appreciate you folks taking the time. Jim, Greg, Antonio, and Raj. I also want to, again, underscore and point people in the direction of the report, which is, again, available at www.semiconductors.org and www.bcg.com, as well as other resources that we have on our website at SIA that help sort of explain the industry, explain the benefits of the industry, and show why it's important to support this very critical and strategic industry. So with that, let me go ahead and wrap up the webinar. Again, thank you all very much, and we hope to stay in touch and continue the dialogue.
Thanks.
Thank you.
Bye-bye.